Welcome to the lecture series on soft computing in computer science. In the last presentation, I have introduced the concept of soft computing and its various constituents like artificial neural network, fuzzy logic and genetic algorithm. In the present day scenario, many have heard about the term artificial intelligence, machine learning, deep learning and so on so. So, I devote this presentation to tell you what are all the related terms associated with the soft computing and what is the similarity between AI, machine learning, deep learning, neural network, so those kind of stuffs. So, in this presentation, so what we are going to see is, we are going to see the introduction about soft computing and in general what is the objective of programming, how to develop a soft computing model and what are the similar analogies of soft computing techniques and where the soft computing techniques have been inspired from, and in practical what is the difference between human as well as the machine, and what is the major difference between learning that had taken place in a human as well as the natural intelligence and well machine learning, various forms of machine learning or different ways of obtaining artificial intelligence. So, particularly and more precisely, this presentation is prepared keeping in mind that the listener should come out of very clear cut idea that among the various associated terminologies like artificial intelligence, machine learning, soft computing, neural network, what these stuff and all, So, the idea is to make clear what these stuff and all by the listener, right. Okay, let me go into the presentation. Let me introduce again what is soft computing. When you look at the definition, you could see that soft computing is an umbrella term. It means it is used to describe different types of algorithms. So, what are the different types of algorithms? As I said earlier, neural network, fuzzy logic and evolutionary computation, that means genetic algorithm. These are the different sets of algorithms whose objective is to produce approximate solution for some sort of unsolvable higher level problems in computer science. This term soft computing is coined in the year 20th century. During this period, various revolution has been taken place. So, all that has been happened into three different sectors. First is neural network. What is neural network? Neural networks are nothing but something like a computational model who has inspiration from the human brain and its associated learning ability as well as the recall behavior. Next is the fuzzy logic. Fuzzy logic is a computational paradigm which always tries to solve or tries to resolve the uncertainties present in the data by means of the truth values between 0 and 1. Finally, the evolutionary computation. It is a term that is got its inspiration from biological evolution as well as the natural selection process in order to solve a kind of problem that is needs optimization. So, this is the again the basic introduction to the topic soft computing. So, overall whatever it is, whether it is hard computing or soft computing, you have to do programs and your objective is differing with respect to programming in hard computing as well as programming in soft computing. When you go for doing a program in hard computing, the input as well as the program should be presented to the computer. The computer will take the program, accept the input and execute the program according to the instruction and produce the output. So, that is a traditional programming model. Whereas in case of soft computing, what you have to do is the computer should be fed with input as well as output, and it is the duty of the soft computing model to make the computer to understand the relationship between input and output. What is the underlying relationship? What are the ways in which the input variables are correlated with output variables, and what made these set of input values to produce a particular output? All these things the soft computing model should do within the computer as a process, and then it gives out some sort of programs. So this is the fundamental difference between the programming objective in hard computing as well as soft computing. With this programming objective, now let us see how to develop in general any soft computing model. If you are interested to develop a soft computing model, you need the input first. Input here I term as data. This data, whatever may be the soft computing model that you are going to develop, whether it is neural network based model or fuzzy logic based model or evolutionary computation based model, it needs a data or it needs some mathematical functions based on some data. The first step is to consider the data in two different stages. One is training stage with some sort of training data, another one is a testing stage with some sort of testing data. During the training stage, the model is being developed pertaining to the data that you have in your hand for training. During those process, what has happened is the parameters are adjusted and the structures are reframed. I will tell you in detail in the subsequent presentation what are those parameters, how to adjust those parameters, and what is the structure, how to reframe the structure and all. So these are all happened during the training stage. Now what is obtained in the training stage? A complete trained model for the data that we have taken into consideration. Now what we have to do next? We have to enter into the testing stage. But in the testing stage, the trained model has been tested, whether the trained model is effective enough in order to produce an accurate result or in order to produce an expected results from the test data. So the major goal in the testing stage is to verify the correctness of the trained model. So if a model passes these two stages of training and testing, then you may say that the developed soft computing model is now ready to deploy and go for further stages of development. So whenever you want to develop any soft computing model, this is the general practice one has to follow. Accepting the data, considering the data into two portions like a training and a testing, then using the data for training, develop the model, then the developed model should be assessed for its performance in the testing stage. So this is the general practice. Next, now you have simple confusions over. I have heard this kind of idea with respect to the term called artificial intelligence and what it is. Now I can define artificial intelligence in the broadest sense as intelligence exhibited by machines. Particularly the machines I can call by the name computer systems, right. So in general, artificial intelligence is a field of research in computer science that develops and studies methods and software. That means it is whose aim is to develop some sort of software. So what sort of software it is? That software enable machine to perceive the environment, that means to understand the environment, to make known about that environment by means of some learning. Through learning, some intelligence has been obtained. With the help of that intelligence, it has to take some actions and it maximizes their goal. So overall, such machine which can perform actions on its own according to the instructions are collectively called by the name AI. Now there are another word in the literature, it is called computational intelligence. What it is? It is nothing but design and development of some biologically as well as linguistically inspired computational paradigms. So that means these three terms, again what are the three terms? Neural networks, fuzzy logic and evolutionary computation. Here the neural networks and evolutionary computations are biologically inspired model, whereas the fuzzy logic is the linguistically inspired model. Overall, this kind of computational intelligence has been well applied for some sort of gamings and cognitive development systems. Now again comes to the picture of soft computing. As I said earlier, this is nothing but in the context of the artificial intelligence and the computational intelligence, soft computing provides tools to handle real world problems. Again the tools are neural networks, fuzzy logic and evolutionary. I hope now you come to a clear picture with respect to AI, CI and SC. So AI is the broadest term where which the computation, if it drives its idea from biologically and linguistically inspired models, then it is going to be computational intelligence, and if it tries to produce approximate results when it tries to solve the problem by means of the computing procedures, then it may called by the name soft computing, right. Now still more buzzwords are there. Machine learning. What is machine learning? By the name implies, if you could see that, learning a machine. That is, I have to teach a machine and the machine has to learn, right, so that the machine can work independently on their own, right. So that is the idea behind machine learning. And how can I teach the machine? I can teach the machine only with the input, that means only with the data. So machine learning is in general is a subfield in artificial intelligence, and it is always associated with development of some statistical algorithms, and those algorithms are very effective in terms of learning from the data. Once it gets learned, it has the capacity to generalize for the unseen data. So that is the major fact, and it is capable of performing any task without any explicit instructions. So what I am trying to convey to you is, making a machine to learn, once it gets learned, it has to work on its own without our instruction. So that is the machine learning. So again it deals with development of algorithms, particularly from statistical field, right. So neural network can also be treated as one of the algorithms, falls under the machine learning. Now comes another term, deep learning. So what it is? Again this deep learning is a subset of machine learning, and it is completely based on the idea of neural network. Why the word deep is there? Because I will in the subsequent presentation we will teach further or elaborately with the idea of deep learning as well as the deep neural networks. But as of now you can say that it has many layers, and we can say that it has multiple layers in a neural network model. Then it is going to be deep learning, right. There is another buzz term in the literature, that is data mining. Many have wondered, AI, CI, soft computing, machine learning and deep learning, and then what is data mining? See, data mining is nothing but extracting knowledge from the data. Who will extract the data? Computer will try to extract the data, extract the knowledge from the data. How the computer will extract the knowledge from the data? Based on some algorithms. Where the algorithms comes from? Those algorithms comes from biologically inspired models or some statistics. So overall, when I call or when I say without the human, if I want to do any job in an artificial way, not by the natural way, they are called artificial intelligence. When I do some computation with respect to producing some intelligent results like a human being, then it is computational intelligence. When I say I don't want to apply some hard and strict rules, I want to apply the soft nature as well as the flexible as well as the adaptable nature of the human being with respect to computation, then I can say soft computing. When I say my objective is to make a machine to learn the environment, learn the data through some algorithms, then the subject becomes machine learning. When I say the machine has to learn the data not with the help of a single layered model, but with the help of many layered model, and each layer is responsible for its own task, then I can say that it is a deep model. And when I focus on the data alone, when I see the data and I want to think about, I have to extract the hidden information from the data. Those hidden information are treated as knowledge because it is going to be used for some sort of higher level decision making. So then I can say that it is a data mining. So these are all the different analogies one can view under the umbrella of artificial intelligence. So in general, what are the inspirations of soft computing? Again insisting you that using the human brain as the source of inspiration. When I use human brain as the source of inspiration, so what is the model that comes out of this inspiration from the human brain? Definitely it is artificial neural network. And you can view this artificial neural network as a parallel distributed systems that are highly massively connected like a mess with a lot of neurons that are highly interconnected with one another. There are many types of models in it: feed forward, recurrent, self-organizing, convolutional, deep. So like that, so many things are there. Overall, what is the inspiration of this model? Its inspiration is human brain. And next, fuzzy systems. What is its inspiration? Its inspiration is the human language, that is linguistic. We will use some sort of terms very much, less, low, not that much far, it is very nearby. So those kind of linguistic terms contain lot of uncertainties. We may not sure, it contains lot of imprecision. So we want to generalize those kind of statements, those kind of problems for which we need approximate reasoning. In that situation, our traditional bivalent logic get failed. In that situation, we need that multi-valued logic. That multi-valued logic is called by the name fuzzy logic, right? Next comes the final inspiration, that is inspiration from the biological evolution as well as natural selection process. So as per the Darwin's evolutionary theory, living creatures are not formed as such, they get evolved from one form to other form, other form to other form, other form to other form, until it gets fit into that model, that is survival of the fittest according to the fittest principle. So this is the yet another inspiration, and these kind of steps are very popularly used for solving and optimization problems. Under this category we can find a lot of things under evolutionary computation like swarm intelligence, genetic programming, evolutionary computation strategies, differential evolution, so many things. Also you may have not a single objective, you can have multi-objective optimization also. So these are all the pictures of our soft computing which has got its inspiration from human brain, human language as well as biological evolution. Here I want to introduce some fundamental difference between human and machine. Look at the picture. What this picture says, a teacher is there or some person is there and she is dictating, who is your father, to whom the questions are fired. One is to a small baby, another one is to a machine. Here the machine I took an example as a computer. Can you say what is the answer said by the baby as well as by the machine? When this question is posted to a baby, that is human, it will react to the question in his own way. Whether the same question if you post it to a machine, whether it will get react, whether it will give answer. So this is the scenario. If you deeply analyze this scenario, you may come to a point that when a question, who is your father, is asked to a human, here human I have taken example in the baby form. So what is the thing is, can recognize but can't answer. Yes, of course, when 10 to 20 gents are standing in front of the baby, automatically the baby crawl towards the one who is familiar. might be his father. So being in the baby form, the baby cannot say by its mouth, by his mouth, this is my father and my father is doing the so and so, because it is a baby form. But the baby can recognize. So that is the one of the wonderful activity of that human being. The same question if we pose to the answer, posed to a machine, that means computer, it can't recognize as well as it's got answer. No computer will say you my father is Charles Babbage, right? Do you agree with this? I think yes. So this is the fundamental difference between human versus machine. So what is the fundamental difference? Yeah, human can recognize but can't answer, but a machine can recognize as well as can't answer. So this is the fundamental reason. But we can make both the things, human as well as machine, to do recognize as well as answer, right? How? Let me take the human as a first example. So that means when a human is learning, some sort of intelligence is built up, and over the period he could be able to teach, say his father name. In the previous example, if I ask you a question, who is your father, what is that baby is telling? The baby won't tell anything because he didn't know how to speak out, but he can recognize the father. But over the period of time, the baby is starting speaking and starting giving answer to whatever the question you are asking, right? So it means that in the baby form, it is the duty of the parents to teach the kid. So over the period, so many people are involved, maybe in the kid form, parents and teacher, maybe in the children form, child form, parent, teachers as well as friends, maybe in the adult form, parents, teachers, friends and society, maybe in the young form, parents, wife, friends, colleagues, so like that and all, right? I hope you understand this evaluation. How it is evolved from a baby form to the elder form. So many people are involved, so many things are involved, and all these things are happen to make the human learn, and the human is learning everything from everyone, and automatically some sort of intelligence is built. Above all, it is book or it is any lecture or it is any talk which makes the human to learn about something else. According to its learning capacity, according to its learning, the human will get some experience, and with the help of that experience he could be able to solve certain problems. So this is the way humans are learning. Now what is happened? You are learning soft computing, right? You are all listener and I am a tutor and I am teaching a subject soft computing to you, and you are all learning this subject. So in such a way, in every walk of the life, every human is learning something else, and intelligence is being built on the human being, and once upon a time he become an experienced expert person. So normally if you face any problem in your day to day life, you try to solve the problem on your own. How? Because you have some experience over that problem, might be you heard about that problem, might be you saw the problem. If at all possible for you to solve the problem, definitely to whom where you will go and address your problem, you will go to the elders and you will go to some parents and you will address your problems and try to get some solution out of the problem. So that is the general practical scenario of our natural life. Now come to machine learning, or something called intelligence that are created in a natural way. Like the human being which are stated from the baby form to the elder form, here also I make machine in the order of very primitive 0th generation machine of computer to the present day smart form of mobile phones. In all the cases, what do you need in order to make the machine to learn? Algorithm, right? So every machine has been created first by means of some algorithms. What is an algorithm? Step by step procedure to solve any problem in order to find the solution. So how this algorithm is getting differed? Algorithm is getting differed by means of the nature of the data. So if you present a data, and if the data is of some kind, some sort of algorithm is required. If the data is of different kind, and some sort of algorithm is required. So based on the nature of the data, some algorithms are developed and algorithms are converted into codes, that means a set of executable instructions, and those executable instructions are fed into the machine so that the machine will run and execute or perform certain tasks according to the instruction. So the data is treated as the one which is meant for say a topic for understanding, topic for learning. The algorithm is treated as a teacher which makes the machine to learn the data. So now the machine is said to learn. Once the machine is said to learn, what it can acquire? It acquire intelligence in an artificial way, right? That is artificial intelligence. Overall, the picture that is required is problem context. So the problem context plays the fundamental idea from which data has been created, and the data we derive some algorithms in order to solve the data, or in order to find solution to the data, or in order to make use of the data for creating the intelligence in an artificial way or making the machine to learn. We have developed some programs or set of executable instructions which makes the data to be in a readable or to be in a decision making possibilities with the help of knowledge extraction and all, right. So this is machine learning as well as artificial intelligence. Now comes to different forms of machine learning. In the literature, you can say that a machine learning can be conducted with variety of strategies. So those strategies are otherwise called by the name different ways of obtaining artificial intelligence. So what are those strategies? If you look at the presentation, the strategies are supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. These are the different strategies. So what I can say to you from here is, here you can see that data. So the data is treated as some sort of what can I say subject by means of which it has been organized into some sort of units, and humans are allowed to treat the subject in order to create intelligence over the subject. According to the nature of the subject, the learning behavior changes. Likewise, when you get into the machine learning topic, the learning of machine, that is in order to understand a particular idea or in order to create intelligence in an artificial way, there are 4 different kinds of learning: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. So if the data, that means if the subject is very simple enough, then supervised learning is sufficient. If the data is complex, then you may go for some sort of supervised learning, that means semi-supervised learning. If the data didn't contain any other information apart from only the basic information, then you go for unsupervised learning. If the data contain different patterns, then you can go for reinforcement learning, right. Say for example, if the data contains very complex topics, one unit is a mathematics unit, one unit as a theory unit, one unit as a programmatic unit, one unit as a case study, one unit is a mini project. It's like that. If their data, like if a subject, say for example, if a student is studying a subject which contains all these categories of difficulties, definitely what he will do? He will do, and he will expected to do in-depth understanding over the subject. We will say to our student, right, dear student, this subject is a very complicated subject. You need not take this subject in a very lighter sense. You need to concentrate on more on the subject. You need to understand more on the topics. So you should do a depth understanding over the subject. So that needs a depth learning about a subject. Likewise, if the data is highly complex, you need a kind of algorithms. Those algorithms are called deep learning algorithms. So these are all the some ideas that I wish to make you to understand the different strategies. Now come to the hierarchies. So as I said, artificial intelligence is the rooftop. It is a very great umbrella or a sky over which we have computational intelligence, over which we have soft computing, over which you have machine learning, over which we have neural networks, and finally deep learning. So this is to make you to know about different analogies as well as the various hierarchical levels of different what can I say, different terms that are used in the literatures as of now. So what we have learned in this lecture, I try to make you to understand what is a soft computing model and its associated analogical terms. What are those terms? Artificial intelligence, computational intelligence, soft computing, machine learning, deep learning, data mining, and inspiration of soft computing. Neural networks inspiration is human brain, physiologic inspiration is human language, and evolutionary computation inspiration is biological evolution. Finally, I wish to make you to know about what is the fundamental difference between human and machine in terms of learning as well as in terms of creating and intelligence. So with this we will come to the end of the this presentation. I thank you. In the subsequent presentation we will learn more about the various soft computing constituents like neural network, fuzzy logic and genetic algorithms one by one. So thank you for your listening. Thank you.